Okay, we're going to go ahead now and write a practice program using arithmetic and variables. So here's our practice program. Write a program that outputs the following. So you see that we have three columns here. The first one is a number. We go from 0 to 5. The second one is going to be the square of the number. And the third column is going to be the cube of the number. Now, we haven't learned about loops yet. That's probably the way that I would go about writing this program if I were to do it myself. So we're not going to be using loops. We're actually going to be putting a number of printf statements. We're going to format our output, and we're going to use arithmetic using variables to make sure that we have everything printed out exactly the way that we want. So to get started on this, what we need to do is run Visual Studio. So everybody find Visual Studio wherever you installed it on your computer. On my computer, it's under All Programs, Microsoft Visual Studio. I'm using Visual Studio 2010. If you happen to have 2012 or 13, it's not going to make any difference on this program. Go ahead and run it. Everything is going to look the same. The code is going to be the same as well. Okay, Visual Studio has now opened for us here. The first thing that we do is we need to create a new project. There's two ways to do it. One, you can click on the new project link that's right here in the middle, or the way that I always do it is go up to File, say New, and then there's a link that says Project. Click on that. That'll open up a box for us here. Make sure that we have Win32 console application selected. Let's give it a name. I'm going to name mine Lecture 2. The location, you can change this location. Just needs to be somewhere that you can write. Remember that if you change this to be your USB drive or some external drive, you may have a little bit of a delay when you're compiling and running your programs because it has to go through those extra steps of getting all the way out to your USB drive. My suggestion, run it off of the local hard drive for now, take note of where that is, and then copy those files onto your USB drive after you have finished running your program and you're ready to take it and move it to another computer. Say OK. That should open up another little box for us here with a few more options. Click on the application settings, make sure console application is selected, and then check the box that says empty project. After you've done that, click on the button that says finish. This should create a new project for us. We see the Solution Explorer over here on the left hand side. If for some reason you don't see the Solution Explorer, it's very easy. Go up to the View menu and then you have a link that says Solution Explorer, and that'll pull it up right here on the left hand side for you. After we have this, right click on Source File, say Add New Item, and you're going to click the CPP, the C++ file. We're going to give it a name. Today's I'm going to name arithmetic.cpp. Doesn't matter what you name this, you can name it whatever you want, and then click Add. That'll give us that nice big screen in the middle so that now we can finally start typing code. Now, I understand that I am going through these steps rather quickly. With this being an online lecture, feel free to pause the video so that you can catch up, go back, listen to what I say again, and make sure that you stay up to what we are typing here. It's very important that you try to follow along with me. I know that I type fast and that I'm going quickly through this. It's very important that you follow along and that you type it yourself rather than just trying to grab the file that we write that I have posted on the lectures page. That's not going to be the best way for you to learn how to program. The best way is you just have to program, and you have to program as much as you possibly can. So I would recommend that you write the code along with me when I'm doing it. Obviously you're going to be writing all of the homework and other programs that you can find in the book or that you find online. I would suggest that you get practice writing those programs as well. The first line of code that we need to have in any of our files is going to be #include stdio.h. This is going to allow us to do standard input and output in C. This is what gives us the ability to call the printf function. If we didn't have that #include standard.io.h header file, we would not be able to call the printf function, and there's going to be a number of other functions that we're going to learn that we're not going to be able to call. This is what we need anytime we're doing any kind of input or output in our C program. The entry point to our program is the main function. The syntax of the main function is void. That's the return type of the function. We then have the name of the function, which is main, followed by the parentheses. There's no parameters, so there's nothing inside of the parentheses. We then open our curly brace, we go down a couple lines, and we close our curly brace. That is the syntax of the main method. Now, last class when we wrote our Hello Moose program, all we did was said Hello Moose, exclamation mark, quotation mark, close your parenthesis, followed by a semicolon. And that worked, and that prints out hello moose for us. Today we're going to make a little bit more sophisticated of a program. We're not just going to say hello moose, but instead we are going to print out the values of 6 different numbers from 0 through 5. Then we're going to print out the square of those numbers, and then we are going to print out the cube of those numbers. So I'm going to delete that printf that I just typed in there, and I'm going to create some variables. I'm going to create some integer variables. I'm going to name them aptly, so I'm going to create a variable called 0. And I'm going to create a couple more variables, 1, 2, 3, 4, and 5. I'm just going to show you a couple different ways of how we can create variables. You see here I've created the variable 0. I've assigned it a value right off the bat. Here I've created 5 more variables on that line. I haven't assigned any values to them, so now I'm going to assign some values to them. If I was writing the program, I would make things a lot more consistent than this. I'm just trying to show you that there are different ways that we can go about doing the exact same thing, and they're all going to work exactly the same way. One way is not more efficient than another. When we start to get into efficiency issues, I'll explain to you which way is more efficient than another. The compiler is somewhat intelligent, and it's going to optimize this code, so it's going to make it run exactly the same as if I put them all on one line, if I put them all on separate lines, if I gave them initial values on the same line or on separate lines. The compiler is going to optimize it and make it all work exactly the same way and run at exactly the same speed. So now I've created my 6 variables from 0 through 5. I have values assigned to each one of them. Now I can actually output the first line of what I want. So let me jump back to my slides here. So you see the first thing I want to do is I want to print out number followed by, any guess what we have right there? It's a certain number of spaces, but instead of it being a certain number of spaces, it's actually one of our control characters, the escape characters we talked about earlier. This is our \t. So it's a tab character right in the middle of number and square, another tab character in the middle of square and cube, a new line character after cube. Then we're going to have the 6 dashed lines followed by a tab, 6 more dashed lines followed by a tab, 4 dashed lines followed by a new line, and then we're going to start printing out our values. So let's get these first 2 lines done, and then we'll come back and figure out how we're going to print out these different numbers on each line. So we need to print out number followed by a tab, square followed by a tab, cube followed by a new line. So let's go back to Visual Studio. To do that, I'm going to call printf. I'm going to print out number followed by a tab. I could end it right there. And then I'm going to print out square followed by a tab. And then I'm going to print out cube followed by a new line. Okay. Another way that I can do that, I'm going to comment this line out in just a second, but to show you another way I can do it, I can put them all on inside of the same printf statement, and that works exactly the same way. So I can separate them into 3 different printfs, or I can put them all into the same printf. And the output to the user is going to look exactly the same, because what this line's saying is print out the word number, follow it by a tab, then print out the word square, follow it by a tab, and so on. You see up here in this printf, I say print out the word number followed by a tab. I never said put a new line, so this word square is going to appear on the exact same line that the word number appeared on. So those 3 lines there are equivalent to the 1 line that I commented out down below. The next thing that I want to do is I wanted to print out those dashes. So 1, 2, 3, 4, 5, 6 dashes, followed by a tab. 1, 2, 3, 4, 5, 6 dashes, followed by a tab. 1, 2, 3, 4 dashes, followed by a new line. And that's going to give me those dotted lines underneath number, square, and cube. So I'm just formatting it so that it looks the way that I want it to. Okay? If you want, we can go ahead, compile that up, run it, make sure that it works. It should print out number, square, cube, all on the same line. And then on the next line, we should have 6 dashes with a tab, 6 dashes with a tab, 4 dashes with a new line. To build it, test it, we go up to build, say build solution. Down here at the bottom of our screen, it's going to go through some build procedures. It's compiling it, and then all of a sudden it should pop up, and if you write perfect code like I do, it says build succeeded. If for some reason you have errors down there, we need to figure out what the problem is. Let me show you an error. I left off a semicolon. Now let me go ahead and build. See what happens with left off a semicolon? It says build failed. Uh-oh. The way that I can figure out what's the problem is you go up a little bit and you see right here it says On arithmetic.cpp, this number right here represents the line number. Syntax error, missing a semicolon before the identifier printf. That's a pretty descriptive error message. If I double click on it, it'll actually even take me to the line that it thinks the error is on. In this case, it actually took me to the next line, but it took me very, very close to where the error is. So you start looking around real close to where it finds that, you'll see that we're missing a semicolon the line before. Put the semicolon there, save it, build it, and hopefully it says build succeeded. Debugging your code is definitely a skill. You're going to need to work on it. You all may have other errors in your code right now. Look at the code that I have here on the screen and make sure that you copied it exactly. C is case sensitive, so if your names are capitalized as opposed to lowercase, it is going to make a difference. You have to make sure that you type it the same syntax that I do, and it's very, very specific in how it is. There's a reason for this. Programming languages have to be context insensitive, so that regardless of where you have a line of code, it's going to be interpreted the exact same way. It is not like a natural language, which is context sensitive, where I can say one thing right now in class and you're going to take it one way, and if your friend says the same thing to you at home, you might take it completely differently. That's a context sensitive language. Programming languages are typically not context sensitive. They're going to be interpreted exactly the same regardless of where you see that line of code. When you see a printf statement, it is going to print out to the screen. It's not based on what else is going on around it. So that's the difference between natural languages like the spoken language, that is context sensitive, and programming languages, which are context insensitive. Okay, let's look back at what our output, oops, we didn't run our program yet, so once you get it succeeded, let's go ahead and run our program, start without debugging, and you see what I told you we would. I see number, square, cube, all on the same line, separated by tabs. Cube has a new line after it where I have my dashes underneath each one of those, another new line, and then I have my press any key to continue. So far, so good. If you don't have that working right now, pause it right here. Make sure that you get that much working before you move on and start writing more code. Best strategy that I can tell you for new programmers is you want to write just a couple lines of code, compile it, run it, make sure that it works. If you try to write too many lines of code and then compile it, you're going to end up with way too many errors, and it's going to be very overwhelming at first for you to figure out where the errors are. So I would try to compile frequently, run your program, even if it's not going to do much, at least run it, make sure that you know that it's going to compile, and then move on and start adding some more lines of code in. Okay, looking back at our program, what we need to do now is we need to print out this number. So this entire column right here is going to be represented by those variables that we created, 0, 1, 2, 3, 4, and 5. This column here is going to be the square of those numbers. So this would be 0 times 0. This would be 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. The last column here is going to be the cube, 0 times 0 times 0, 1 times 1 times 1, 2 times 2 times 2, and so on. Now, the way that we print things out, as you've seen, is we print them out horizontally. So we can't print the entire column first and then go and print the second column. We have to print out line by line. So we're going to need to print out the value 0, then print out the square of 0, then print out the cube of 0, followed by a new line. Then print out 1, print out the square of 1, print out the cube of 1, followed by a new line, and so on all the way until we get down to 5. The way that we're going to do that, our next printf is going to be, we want the value the value 0, followed by a tab, the value of 0 squared, followed by a tab, the value of 0 cubed, followed by a new line. Then I want to print out the value of the variable, the value of the variable 0, then the value of the variable 0 squared, then the value of the variable 0 cubed. Now, I used the parentheses here just for emphasis. I didn't need to put them there. The order of operations is that the multiplication would occur before the comma occurred. I did that just so that it's a little more clear that we see that the first %d is going to get the value in this variable 0. The second %d is going to get the value of 0 times 0, and the third %d is going to get the value of 0 times 0 times 0. Another way that I can do that, and I'll show you how I would do that here with the number 1, is that I can create other variables. I'm going to create a variable called 1 squared and 1 cubed. Syntax that we have in C, all variables have to be declared at the top of the function. So you see I just moved it up there where I have 1 squared and 1 cubed. And then here I can assign values to those variables anywhere that I want, but I just need to declare the variables at the top of the function. So now I've created 1 squared and 1 cubed as additional variables. I've given them their values here of the square of 1 and the cube of 1, and then I can do a similar printf statement to what I just had. And now instead of actually doing the arithmetic in the printf statement, I can just say 1 is the first variable, 1 squared is the second variable, and 1 cubed is the third variable. And that'll print it out exactly the same way. It's your choice how you go about doing the rest of them for 2, 3, 4, and 5. Take your pick on which way that you want to do it. If you want to do it in line like this, or if you want to do it by creating other variables like this. So I'm going to go ahead and just do it in line. I also am not going to be copying and pasting anything. Copying and pasting is a bad technique to get into whenever you are programming. If you find yourself copying and pasting, that means that there's probably a better way to do it. I already told you this is not the way that I would have gone about writing this program. I would have used a loop, but we haven't learned loops yet. So we're going to go about doing it this way. I just want to make sure that we get into a good programming technique of not copying and pasting anything. So I'm just going to go ahead and type it all out. If you do decide that you want to copy and paste, make sure that you change all of the variables, because chances are you will forget one of them and then something is not going to appear right. And you will end up spending more time debugging that rather than if you had just typed it out again yourself. Students often say that their typing speed when they take a class with me goes up by at least 10 words per minute during the semester. With you being able to pause the video, you may not have that same effect, but if you're trying to follow along with me in real time, I can probably believe that that would be the case. Almost done here on the last line. 5 squared and 5 cubed. After you get that, save it, build it, run it. Let's see if we get the same output that we had in our example. There's the output. You see I have my 0 squared and cubed. I have my 1 squared, 1 cubed, 2, 4, 8, 3, 9, 27, 4, 16, 64, 5, 25, 125. Let's go back to our slideshow. Go back to our output, check to see did we get the exact same answer. We did. That means that we succeeded. There are multiple ways to write this program. This is still one of your first programs that you're writing, so bear with me. We're going to get better. Things are going to get faster. You're going to start to understand a little bit more. But there's your first program. Everything's working. I'll go back to it here for you. Let me see if I can get it all to fit on one screen for you. I tried to space it out a little bit so that it was a little easier for you to understand. There is the entire program, though. That's going to wrap up our program for today. If you have any questions, let me know. I'll post this on the website. The video will be posted, and I will talk with you all later.